Welcome to the podcast, Santosh. Can you introduce yourself?
My name is Santosh Hari. I live in Orlando, Florida. I am a Microsoft Azure MVP and a public speaker. I've spoken at many tech events, including code camps and regional and international conferences. My day job is I am an Azure consultant at Nebbia Tech, and I have over 20 years of experience in the software industry. I have been involved with tech startups, co-authored software patents. I'm also deeply involved with the local community in Orlando. I help run the Orlando .NET user group and also co-organize Orlando Code Camp.
You've been also working on CosmosDB, right?
Yes.
Do you know what CosmosDB is?
Yeah, sure. So Cosmos DB is basically NoSQL database as a service. So it's similar to how you have platform as a service and infrastructure as a service. Cosmos DB is a NoSQL database as a service. It's provided by Microsoft Azure, which is Microsoft's cloud platform, and it is actually only run and hosted on Azure. There is no instance of Cosmos DB, for instance, that runs on AWS or anything like that. It's only on Azure. Because of that, the database platform and infrastructure are fully managed by Microsoft Azure. This means that you can distribute your data to the 54 data centers that Microsoft Azure has all over the world. And you can do this with Cosmos DB. And because it's a Microsoft product, they also have really good tools and SDKs that will help you store and manage your scaling and distribution, and also the storage of data. Because of this, Cosmos DB is a great platform to handle large amounts of data, particularly in fields like gaming, IoT, and other web scale applications.
Great. Do you know some use cases for CosmosDB? You mentioned gaming.
Cosmos DB is a NoSQL database, and the advantage of Cosmos DB is that it's not just like one type of database. It's got like four different types of NoSQL database. So for instance, Cosmos DB can host document oriented data, which means that the data is stored as JSON documents. So this means that it has two different types of document data stores. It has SQL API, which used to be called Document DB, and not to be confused with Amazon's current product known as Document DB. This is an old one, which is now called SQL API. So not confusing at all. It also has another document store called MongoDB, for that supports data for MongoDB. So what the use cases for document databases is generally products that run large scale storage of kind of related data, but on a very flat level. So for instance, like if you do a product detail page, for instance, if Amazon wants to host a detail page for each one of their products, they can do that. And what they could do is, and I say Amazon, but any kind of e-commerce vendor, they could host their product details page, and they could put that on a document and distribute it across the world. And that way, when you retrieve the data, it doesn't have to go and each time read the data from 50 different tables to populate it on the page. It can pull in that single document and display it on the page. So as a result, it's really good for those kind of use cases. Now, Cosmos DB also has table storage, and that is kind of like a key value pair. So basically a key value pair means that you can look up a value by just providing the key. So if you're familiar with algorithmic costs, this is a O of one cost, which makes it super efficient. So you can use it for storing tabular data and then looking up stuff as keys, or so you can also use it for things like caching and reading the data from sessions and stuff like that. So the third type of data storage that Cosmos DB offers is called graph NoSQL databases. So it offers this over the Gremlin API. Now, what graph databases are is a set of super relational databases, which means that you can use it to form or describe really deep relationships. So all you have is something called edge and a vertex. A vertex is actually a object, and a edge is basically the relationship between two objects. So you can randomly add and remove objects and form relationships between objects real easy. And this makes it really useful for cases like like storing relationships like in social media and other places. So for instance, if you go and look up LinkedIn, it tells you that someone is related to you immediately. So it would be like first level relationship, or someone who knows someone. So that is a second level relationships. So you can go like 10, 15, 20, 100 deep, and graph databases are really good for this. And finally, it also offers column-oriented NoSQL storage using something called a Cassandra API. And what column storage is instead of storing data in rows, it groups them by columns. The advantage of this is that because the data is stored by columns, grouped by columns, they can be stored on the same physical storage together. So if you had things like time series data and you want to aggregate data over a time series, you can group it by columns, and because they're stored close together on physical storage, that makes aggregation operations really efficient. And the use case for this one would be in a time series analytics type data. For instance, let's take Google Analytics. It collects data over time and then it aggregates and presents it back to you. So Cassandra would be a really good use case for that. So those are the general use cases, but keep in mind that because Cosmos DB provides four different types of NoSQL storage, you don't have to be restrict yourself to one of these. You can use all of these if you want in your application. So that is called polyglot persistence. And to me, that is the biggest appeal of Cosmos DB.
You also mentioned that Cosmos DB is a NoSQL database. It is supporting a non-relational database. So how is NoSQL different from SQL that we normally have?
Oh, excellent question. People are or software developers are generally used to SQL databases, which means that data is stored in tables and each record is represented as rows. So this is how we normally picture data. But there is a problem. So I will talk about the difference between those as, I won't say that this is X feature versus Y feature, but I'll try to describe what problems NoSQL is trying to solve that SQL has. So basically, the problem that SQL has, it has a couple of issues. The first is called impedance mismatch. So this means that let's say you take a record. So this belongs to a person, right? And then this person You want to, let's say this is a social media network like LinkedIn. So you want to find out where this person has worked, and you want to find out what type of skills this person has. So you have the user table, you have a company lookup table, and you have a skills lookup table, and then you have joint tables in between these because it could be a many to many relationships between people and company and skills. So it's like five tables. And if you, for one person, if they had three different skills and they worked at two different companies, that's almost 10 rows of data you require to store that single person's experience, data. So you have to store these 10 records across five different tables. So that is for one person. So imagine a huge system like LinkedIn where you have millions of people trying to store data across 50 different skills and 10 different companies. So it becomes a real mess at that point. So what NoSQL database is trying to do is, and this is caused because of, we normalize data in RDBMS and this is a good practice. And we had to do this in the early days of RDBMS because memory was expensive and we had to be really careful of where we stored things, and we had to be account for redundancy and such issues. But as systems started to scale and became web scale, and huge systems like Facebook and LinkedIn and all of these went online, they figured out that this doesn't work for them. So what they did was they took, like for instance, a person's experience and skills, they took this data and they put it into a single document. So instead of reading it from five different tables from 10 different records, which is an impedance mismatch, you can now read it in a single operation from a document. So that is one problem that NoSQL solves that SQL had. The other problem that NoSQL solves is scaling. So relational databases, they're largely designed to run on single servers, which means that as the number of users and number of connections increases, you have to scale the server up. So you keep scaling up, and at some point, the laws of physics catch up with it. So you can only scale up so much. So what NoSQL database does is instead of storing data on one server, it spreads it across multiple servers, and these are commodity servers, which means that you can have hundreds of servers where you had uh, one. And this distributes the data and the load equally across multiple servers. The added advantage of this is that if one of the servers goes down, the database keeps functioning. Whereas in RDBMS type situations, if one of the servers went down, that's a single point of failure. So this solves both scaling and single point of failure. I would say that NoSQL databases started to catch on in the past decade as systems started to become more web and planet scale.
I think that is very accurate. I see companies like Facebook starting to use NoSQL. Uber is also doing same. So NoSQL has a lot of potential in the future. Now, another point I wanted to discuss with you was what skill do one need to get started with Cosmos DB?
Okay, so that's another great question. So Cosmos DB, as we know, is a NoSQL database. But I feel like if you really wanted to understand the advantages of Cosmos DB, you first have to know what relational databases are and what problems they solve and what the weaknesses of relational databases is. So number one is you need to know relational databases. Number two on this list of skills would be the basic concepts of NoSQL database. And to me, the number one on this would be a concept called CAP theorem, or it's also known as Brewer's theorem. CAP is CAP, so that's consistency, availability, and partitioning. This basically talks about the laws of physics. So consistent, let's take consistency, right? So you have data on, you store your data across multiple servers and you want them replicated. So let's say you store on node 1 and you try to read from node 2. So what happens if the cable between node 1 and 2 gets cut? So that you have to answer those type of questions when you distribute databases. So if it's a consistent database, if you store your data on node 1 and it did not replicate to node 2, and there was some kind of latency or network outage, when you try to read the value from node 2, it will present an error because the data was not replicated, i.e., the data is not consistent. And the second one is availability. And availability is the exact opposite. They solve the exact opposite problem, which means that if data was stored in node 1, it did not replicate to node 2, you can read from node 2 and it will have stale data in it. This means that even if there's some kind of latency or network outage, it actually sacrificed consistency so that the system is available and there are no errors. The third one is called partitioning, which means that if you have node 1 and node 2 and there was a network outage between the two, the system would still continue to operate. Now, however, this is a theorem. There is the real world that we have to talk about, which means that when you have a distributed system, especially one like CosmosDB, what happens is, you take your data and you store it across the world, which means that at some point you have to deal with things like network outage and latency. So this means that partitioning is always happening. Now, the CAP theorem states that you can only have two of three, which means that if you have a consistent system and it's partition tolerant, it won't always be available. So if you go to read a data from a different node and it has not updated for whatever reason, it'll throw an error, which means it's not available. So, you have to pick two of three. That's what the Brewer's theorem states. But in reality, you always have to deal with partitioning of systems. So this means that our system can be consistent and partition tolerant, which means it won't be available at all times, or a system can be available and partitioned, which means it won't be consistent at all times. So that is the reality of the CAP theorem. So that is number one concept. Number two concept is called three V's: volume, velocity, and variety. So you have to understand that if you want to use a NoSQL data store, generally if your data is high volume, which means that it's terabytes, petabytes of data, generally NoSQL is a good fit for that. Velocity. So this means, for instance, IoT sensors, right? You have millions of doorbells and cameras and all of that. So let's say these are consistent. These are suddenly becoming more active in the evenings. The velocity of data that comes into the system at that particular point in time is really high. So if it fits the velocity criteria, a NoSQL data store is generally a good idea. And variety, you have a diverse variety of different types of formats. So you have like tabular data, you have photo, video. So if you see a wide variety of data, NoSQL systems are a good fit. So you have to understand the basics of NoSQL. That's item number two. Item number three for Cosmos DB is you have to have the ability to code in one of the languages. And because Cosmos DB is a Microsoft Azure product and they support almost all the platforms, you can pretty much have the ability to code in C Sharp, Java, Python, Node, all of those, and they have SDK for all of these major languages. And even if you don't if you have a particular language that is not on this list, they still have a REST API. So you should know basic concepts of REST. I would say that because Cosmos DB provides a query language, even though it's a NoSQL database, you can run SQL style queries on it. So because it provides a query language, you should have a basic understanding of query language. And finally, obviously, because it's a proprietary Microsoft Azure product, you have to know the fundamentals of Cosmos DB. And these are things like resource model. This resource model is basically the structure of Cosmos DB. You have to know what partitioning is and how it impacts storage of data. To understand throughput, which is the performance, you have to understand consistency and how it impacts it. And finally, you have to understand the automatic indexing that Cosmos DB does. So you basically need all these skills, but I feel like if you're a developer who's been developing for any amount of time, you're likely to have a decent portion of these skills to get started with Cosmos DB.
I agree with you. Being a user of MongoDB and Firebase before that, so I have some experience in NoSQL. It is good to have tools like Cosmos DB, which allow us to scale horizontally. And you've been using Cosmos DB for some time, from what I understood. So, what are your likes and or dislikes about Cosmos DB?
Okay, I like a few things about Cosmos DB. Number one is it's polyglot data storage, which means you can store different types of NoSQL data in Cosmos DB. You can easily scale, so you can basically click on different points on a map and spin up instances in different regions, and that makes you be able to scale on a global basis. Cosmos DB, if like I said previously, like if you have worked as a developer for a while and you pick up some of the concepts of NoSQL, Cosmos DB is really easy to learn and use. I will. The other thing is its performance. So if you store data in Cosmos DB, the storage and retrieval is in single digit milliseconds, which is really fantastic. That's definitely one of the things I like most about Cosmos DB. And finally, there is this concept called total cost of ownership. So if I am using Cosmos DB, I don't have to worry about spinning up servers and having to power them, maintain them, have a DBA on hand to maintain them, anything like that. So that means my total cost of ownership, if I use Cosmos DB in my product, my total cost of ownership of Cosmos DB, even though it generally comes across as slightly more expensive than Azure SQL, for instance, if you look at the total cost of ownership, it's low because of all these other advantages. And the best part is like the security. Microsoft completely takes care of that, so I don't have to worry about it getting hacked or anything like that. It's got all the security certifications and everything, so that makes it a really fantastic product. And I really like not having those type of things to worry about. Dislikes, I would say that there's obviously I use it quite a bit, so I may be a little bit biased here, but I have very little I dislike about it. But one of the things I feel they could improve on is the cheapest instance, if you ever ran a live application, is about 24, $25, and feel like you can get Azure SQL or some other storage for cheaper. So at a starter level, it looks a little bit expensive, but again, like I said, because of the total cost of ownership, if you think about it like a CFO or a CEO, the total cost of ownership is really low. And I feel like we could have more emulators that run locally across a variety of machines like Windows, Mac, and everything else. So they are still working on a little bit on the local emulator part, so that you can code completely local without being having to connect it to the internet. So those would be my likes and dislikes.
All right, you provided some great insights, Santosh. We have reached the end of this podcast, and I would like to thank you for being here and to allow us to know about NoSQL and Cosmos DB. You are welcome to be on the podcast whenever you want again. You can just contact me. Also, is there anywhere people can find you?
You can pretty much find me LinkedIn. So LinkedIn, just search me by my full name, Santosh Hari. That's Santosh, and last name Hari, Hari. Or you can find me on Twitter, where I'm quite active, and my handle on there is the underscore symbol S underscore Hari. So underscore S underscore Hari. So you can find me on any of those two places, or you can always, search online and you'd probably find YouTube videos of me giving talks on Cosmos DB. Thank you very much.